Hi guys, welcome back. So today, as the title suggests, we are going to be multiplying and dividing rational expressions. But before we do these kind of bad boys, let's go ahead do something that we're a little bit more familiar with. So let's just say that for some weird reason, don't know why, I asked you to find this product. You know, when you were in preschool. So I want to know, what is the product of 2/3 and 1/5? To multiply two or more fractions, we're just going to go ahead and multiply across. We're going to multiply the numerators together, and then we're going to multiply the denominators together. And then if we could reduce it, cool. All right, that's it. Okay, now when it comes to multiplying rational expressions, the idea behind it is the same exact thing. You're going to multiply across and then reduce. But the difference is that because we have rational expressions, it's not going to be as easy to identify the common factor. So before we get excited and actually multiply, we want to factor everything. Factor all the tops, factor all the bottoms, and then do what we did back in the day. So let's go ahead and do this. So fun problem. The directions read perform the indicated operations. So that's code for do whatever the operation states. If we have multiplication sign, then I guess we multiply. Similar for like addition, subtraction, and division. So let's go ahead, look at each numerator, look at each denominator, and make sure that it's factored. For the first numerator, it's just a single term, so there's nothing to factor. For the first denominator, prerequisite step is to watch out for common factors. In this case, we don't have any common factors other than 1. Binomial minus, chances are, is it a difference of squares? Let's check, because I'm not like you where I can just see it. So I'm going to go ahead and do the mold. Do I really have a difference of squares? And I believe we do, because last time I checked, x squared is the square of x, and 4 is the square of 2. So to answer my question, do we have difference of squares? We sure do, and this should factor to x plus 2 times its conjugate. Okay, remember that formula, a squared minus b squared? Yeah, we put it into play. So this should factor to x plus 2 times x minus 2. You know, let me write it out. So difference of squares, a squared minus b squared, that factors to a plus b times a minus b. Okay. All right, cool. So 2 polynomials down, 2 more to go. All right, moving forward, let's look at the next numerator. So that's our third polynomial. Prerequisite step is to watch out for common factors. The GCF in this case is 3. Let's go ahead, factor it. And when we do, first term over common factor gives us x. Second term over common factor gives us 2. Okay, 3 polynomials down, 1 more to go. The fourth one is just a single term, so there's nothing to factor. Now, depending on how you're feeling this problem, you can go straight to attack mode and cancel out. But to tell you the truth, this is a little bit overwhelming aesthetically. So I'm going to go ahead and rewrite this problem where all the numerators and denominators are in factored form. So the first polynomial, we're good. Or the first numerator, same difference. Polynomial number 2, we factored it to x plus 2 times x minus 2. And then we're going to multiply that by polynomial number 3, or second numerator, 3 times x plus 2 over polynomial number 4, or the second denominator. Okay, so you have some options. You can multiply across and then reduce, or what I do, I just like pre-reduce now and then multiply across. So you can look at this globally, but it's really hard for me just to look at the whole thing and be like, bam, what cancels out? That doesn't really work for my eyes. So I just focus either in the numerator and denominator. Denominator is closest to my finger. Yeah, that's the reason. So I just focus on the denominator, look at each factor, and see if there's anything I can cancel it with. So I got an x plus 2. I'm like, do I have an x plus 2 to cancel it with? Yeah, I sure do. So let's go ahead and do the honors. I got an x minus 2. Can I cancel it with something? No. I have a 9. Can I cancel it with something? Yeah, 3. Okay, 3 and 9 have a common factor of 3. So let's do this. 3 goes into itself once and into 9 3 times. How about the x's? Yeah, Okay, I could cancel it with this. We got 4 factors of x. We got 6 factors of x. Last time I checked, I think we canceled out 4 factors of x. And if you're having a moment, vent out your frustrations. Silly exponent rules, they make me so mad. And if you have no idea what I'm talking about, oh, I'm crying because that means you didn't watch my earlier video on exponent rules. Okay, so if we have a division problem, we're going to keep the base and subtract the exponents. So we're always going to subtract the smaller exponent to avoid having a negative exponent. So if we remove 4 factors of x, x to the 4th goes into itself once, and into x to the 6th. Remember, for division problem, we keep the base and subtract the exponents. 6 minus exponent of 4 will leave you with 2, so that will leave you with 2 factors of the base. Cool. I got another factor. Y's. Can I cancel them? Yeah, we sure can. We got 5 on top, 3 on bottom, so guess what? We're canceling 3, okay? Y cubed goes into itself once, and into y to the 5th. Remember, for division problem, we're going to keep the base and subtract the exponents. 5 minus 3 will give us 2, so when we cancel out 3 factors of y, that will leave us with 2 factors of y. Cool. So, unless I overlook something, I think we're good, and in the event that I did overlook something, we'll catch it right now. Let's go ahead and multiply across, okay? 8 times 1 times y times 1 will just give us 8y squared. Why did I circle the factors that are not 1? Oh, that's because I will hate for me to do all the math correctly, but get Dean because I couldn't read my own work. Okay, for the denominator, we have 1 binomial 3x squared times 1, and the product of x minus 2 and 3x squared is just 3x squared times x minus 2. So I know we're cool like that, but sometimes, you know, my eyes fail me, and maybe I overlooked, you know, a common factor. So let's look at our answer one more time and see if it's really reduced. We have a 3. We can't cancel it with anything. We got the x's. Nope. X minus 2, no. Okay, so we actually multiplied. We have confirmed that it's reduced, so we're good. Okay, so we're gonna do one more multiplication problem, and then we'll switch gears to division. So let's go ahead and do this. Problem B, where am I? We have 9x squared minus 64 over, where am I? 3x squared minus 5x minus 8, and then we're going to multiply that by 5x squared plus 3x minus 2, and that is all over 25x squared minus 4. Okay, so for problem B, I feel like the polynomials are a little bit more spicier. So what I'm going to do to help me organize this in a way that I can see it, we are going to, sorry, I'm playing with the light, okay? I'm going to go ahead, take a different spin, and I'm just going to label the polynomials. We have 1, 2, 3, 4, okay? So this is something that I like to do when I don't know how to go straight to answer, like we did in polynomial number 3. And then we want to show some work, but still have a nice way to organize our work. So let's do this. For the polynomial number 1, or the first numerator, we have 9x squared minus 64, and then we have all the space in the world to show our work, if any. Okay, prerequisite step is to watch out for common factors. Does 9 go into this? No, 3 either. Okay, so no, there's no GCF to yank out. Binomial minus, we're going to aim for difference of squares, and if not, difference of cubes. So you know me, it's really hard for me to see things, so I'm going to do the mold, and then if it fits, then yeah, we have difference of squares. 9x squared is the perfect square because it's the square of 3 times x. 64 is the perfect square because it's the square of 8. So to answer my question, do we have difference of squares? We sure do. And remember, if we have difference of squares of the form a squared minus b squared, then that will factor to a plus b times a minus b. Okay, so this should factor to 3x plus 8 multiplied by 3x minus 8. Okay, one polynomial down, 3 more to go. So let's do this. Number 2, we have 3x squared minus 5x minus 8. Prerequisite step is to watch out for common factors. Unfortunately, there's no common factor to yank out. We got a trinomial. Is the leading coefficient 1? No, okay? Because the leading coefficient is not 1, then we're going to go ahead and use the AC method to factor, or you can use whatever technique you came to the class with, okay? So the purpose of the AC method is to help split the middle term. To facilitate the process, we want factors of AC that add up to B, okay? Let me identify A, B, C. We want factors of AC that add up to B. Product of A and C, namely 3 and negative 8, will give us negative 24. Value of B is negative 5. Remember, you're more than welcome to switch the sides. It's okay. Okay, I'm trying to play with the line. Okay. So factors of negative 24 that add up to negative 5. If my eyes don't fail me, I believe it's 8 and 3. But one of the factors will have to be negative. In this case, the larger factor will be negative. Let's check it. The worst thing you can do to yourself is do a lot of math and then realize like, oh, dog breath. That's what my office mate says, you know. Then realize that you made a mistake. It's easier to check now and then work it out later. We keep our cool. Product of negative 8 and 3 is negative 24. Sum of negative 8 and 3 is negative 5. So let's go ahead and split that middle term using the variable part x. Okay. So we have that the first term reads 3x squared. And let's go ahead carefully split that middle term and replace it with negative 8x and positive 3x. Negative 8x, positive 3x, and then we bring down the rest of the problem. Now that we split the middle term so we can have 4 terms, let's go ahead factor by grouping. Okay, we're going to group the first 2 and we're going to go ahead group the last 2. From the first team, 3x squared and 8x have a common factor. I think it's just x. When we factor it out, first term over common factor, that will leave us with 3x. Second term over common factor, that will leave us with negative 8, and we're good. So one team down, one more team to go. For the second group, let's go ahead yank out the GCF, but there isn't any. Okay, so if there isn't any, then the greatest common factor is just 1. We're going to factor out a positive 1. Do I feel weird? Yeah, but it is what it is. When you factor by grouping, you make your teams and then you take out the GCF from each group. First term over a common factor still leaves us with 3x. Second term over a common factor still leaves us with negative 8. Fantastic. So at this point, let's go ahead and love ourselves and then factor out the common binomial of 3x minus 8. So when we do that, let's show the reader what we're left with. First product over common factor, the binomials cancel out, and that will leave you with x. Second product over common factor, the binomials cancel out, and that will leave you with 1. Cool? And I think we're good. Okay, I was gonna box it because I thought that was my answer after all that work. We have 2 polynomials down. We have 2 polynomials down. 2 more to go. Okay, number 3. I need like a little break. Okay, like a real one too, but I need a visual break. Polynomial number 3. We have 5x squared plus 3x minus 2. Cool, fantastic. And then you factor however you like. Prerequisite step is to watch out for common factors, but we don't have any. We got a trinomial. Leading coefficient is not 1. So once again, we're going to have to go ahead and use the AC method to factor. So let's go ahead and do our corresponding x game. We want factors of AC that add up to B. So factors of AC that add up to B. Factors of 5 and negative 2. 5 times negative 2. 5 times negative 2 will give us negative 10. Value of B is 3. So I'm like, okay, what are factors of negative 10 that add up to 3? So I think it's a 5 and a 2, where the larger factor should be positive. So like 2 should be negative. But you know the drill. Let's check it. Product of 5 and negative 2 is negative 10. Sum of 5 and negative 2 is 3. We checked it, so we have the green light to proceed. We shouldn't have any surprises like we didn't in the earlier problem. Let's go ahead and split that middle term using the variable part x. Using the variable part from the middle term. My mistake. Okay, I need to finish my sentences. So we have 5x squared. And we're splitting the middle term to positive 5x and negative 2x. So plus 5x minus 2x. And then we bring down the rest of the problem. Now that we split the middle term, let's go ahead, follow procedure and factor by grouping. We're going to go ahead, group the first two, we're going to group the last two, and then take it from there. From the first group, 5x squared and 5x have a common factor of 5x, and when we take it out from the group, 5x squared over 5x will leave us with x. 5x over common factor will leave us with 1. So one group down, one more to go. 2x and 2 have a common factor of 2, but if you've been following me, remember, well, if you're my student, who else is going to follow me, okay? You have to remember that when you take out a common factor, it would be nice if you fix it so if you start off on a positive note, and who cares if the rest are negative. So we're going to factor out a negative 2. When we do first term over common factor, that will leave us with x. Second term over common factor, that will leave us with 1. Cool. So as expected, the binomial factors match. So let's go ahead and do this. When we factor it out, we have x plus 1, and we're going to show the reader what we're left with. First product over common factor, the binomials cancel out, and that will leave us with 5x. Second product over common factor, the binomials cancel out, and that will leave us with negative 2. Okay, fantastic. So 3 polynomials down. Okay, oh, you can see my check mark. Okay, 3 polynomials down, one more to go. Okay, number 4. Now, do you have to organize your work like this? Of course not. Okay, if you just want to write like above or below the expressions, I'm okay with that. But again, I like to use my notes to prepare for upcoming assessments. So the more organized that I am, the more likely that I will be able to follow my own work. Okay, so it's totally a personal choice. Okay, polynomial number 4 is this binomial right here. So prerequisite step is to watch out for common factors, but we don't have any. Binomial minus, let's see if we have difference of squares. Now someone said, do you need to write this, Molt? Of course not. Okay, you don't have to write it because if you see it, cool, but I love to actually see it, not think it. Okay, so 25x squared, sorry, I jumped the gun. 25x squared is a perfect square because it's the square of 5x. 4 is a perfect square because it's the square of 2. So the bases are 5x and 2. That's our a and b. So this should factor to the form a plus b times a minus b, or 5x plus 2 times 5x minus 2. And if I know how to count, I think we factored all 4 polynomials. So let's go ahead, come back to the table. Okay, so what I'm gonna do, I'm not gonna rewrite the original problem, so I need a break again. I'm not gonna rewrite the original problem because that will take us forever. What I'm gonna do, I'm just gonna write the numbers that we wrote out. So we wrote 1 over 2 times 3 over 4. And the reason why I circle 1, 2, 3, 4 is just to remind me that that's how I number them, so they're not confused with the actual problem itself. Okay, I'm having technical difficulties. Okay, so where am I? Okay, so number 1. Okay, what did polynomial number 1 factor to? It factors to that. Okay, so that gives us 3x plus 8. Oh, sorry. Times 3x minus 8. Okay, so that's 1. Now we're going to write that over what? 2. Where's 2? Right here. Okay, so 2 factor to 3x minus 8 times x plus 1. Cool. What's the rest of our problem? We got a raised dot, so we're going to multiply it by 3 over 4. Where is 3? Okay, 3 is given by x plus 1 times 5x minus 2 all over what? 4. And 4 is given by 5x plus 2, 5x minus 2. Now, do you have to organize your work like this? No. Again, you do it however you want, but I'm just giving you a way to have lots of space to show your work, if any. So we did the toughest part, which is the multiplication. Now we have to keep our cool and then see if we have any factors to cancel out. You can just look at it at once and see what cancels, but my strategy because I don't see things. I tend to overlook things. So my strategy, I just focus on the denominator, one factor at a time, and then see if I could cancel it with something. Okay, so let's do this. 3x minus 8. Can I cancel it with something? Yeah, another 3x minus 8. X plus 1. Can I cancel it with something? Yeah. 5x plus 2. Can I cancel it with something? No. 5x minus 2. Is it happening? Yeah. Okay, we could cancel it with another 5x minus 2. And I think we got everything. So let's do this. In the numerator, we have a 3x plus 8 times, that's it, okay, because it's just times 1. Binomials, parentheses are no longer needed or welcomed, okay. For the denominator, we just have a 5x plus 2. And that's it. Can we cancel more? We can't. Remember, we can only cancel factors. How can we tell if we have factors? We have factors if we have multiplication across. Right here, we no longer have factors. We just have terms. We can't cancel terms. We can only cancel factors. So we either take out the entire 5x plus 2 or nothing at all. Okay, guys, so we're going to do, we just did 2 division problems. Let's go ahead and do 2 multiplication problems. You know what? Actually, let's just cut it right here. And in the next video, we'll do the division. All right, thanks.